Hi folks, we're going to take a look at number 19 on page 51, and this is one of the more interesting problems we've seen. Okay, so let's take a look at what's going on. So it says Carl traveled 1,900 kilometers from his home to Winnipeg, okay, but he didn't do it by one mode of transportation. He traveled first by bus at a speed of 60 kilometers an hour, and then from Toronto to Winnipeg, he flew at a speed of 700 kilometers an hour, okay? And they tell us that the total traveling time was 7 hours. So let's see what and I really want you to focus on this last sentence, because it's usually this last sentence that tells you what your variables should be. It says, how many kilometers did he travel by bus? How far did he travel by airplane? Okay, so while they give us a whole bunch of different type of information, they give us distances, speeds, and they give us times, what we're looking for is something to do with distance. So I'm going to try to keep my variables all to do with distance. Okay, so I'll say let B be, now this is where you want to be careful. You don't just say let B be the bus. B is not the bus. B is the distance the bus traveled. Okay, so you can say B, let B be the distance. Okay, you might even specify the units. So distance in kilometers the bus traveled. Okay, then we have P is going to be the distance, again in kilometers, that the plane traveled. Okay, so you always want your variables to be those things that you're looking for. So now our goal, because we have two variables, is to write two equations using those two variables. Okay, so let's see what information they give us. And the first thing I notice is they give us the total distance traveled. So if I add the distance he traveled by bus plus the distance he traveled by plane, that should give me the total. So that gives me a pretty easy equation. Okay, B plus P has to be equal to 1,900. So there you go. There's my first equation that contains the two variables I'm looking for. It's a second one that's a little interesting because the other information they give us about the total is they tell us that the total traveling time was 7 hours. So essentially what they're telling us is the time he traveled by bus plus the time he traveled by plane is equal to 7. So we have a second equation. The problem is that the second equation is given in terms of time. And I need two equations in terms of distances, which we call B and P. So this is where we notice that they don't just give us this time information, they tell us how fast they're traveling in these two times. Okay, and this is where we're going to use our relationship between speed, distance, and time. We know that the speed is given as distance over time. But our goal is to take this time variable and rewrite it using the distance variable. So what I'm going to do is I'm just going to take this equation and I'm going to rearrange it so that I solve for time. So the first thing I can do is multiply t to both sides of the equations. So I'm going to end up with v times t equals, going to get rid of this t on the right hand side. And if I want to solve for t, I'm just going to divide both sides by the speed. Okay, so all we did was rewrite this equation, which is our relationship between speed, distance, and time. I just rewrote it, so now I've isolated for time. So that means the time is given by the distance traveled divided by the velocity, or the speed during that time. Well, how far did they travel by bus? Well, we don't know. That's what we called B. Okay, now we just have to divide that by the velocity to get the time. And hey, we know the velocity by bus, it's 60 kilometers per hour. Okay, plus let's rewrite the time using distance and velocity. The distance I don't know, but that's the variable I called P. Okay, and I divide that by the velocity, and I know the velocity when traveling by plane, it's 700. Okay, and lo and behold, we have a second equation that has the variables B and P, the ones that we're looking for. Okay, so now it's just a matter of solving this system of equations, which in and of itself is a little interesting because we see that we have to work with fractions. So we'll get rid of this, oops, sorry about that. Get rid of that textbook, and let's now work on the algebra. Okay, so very important. You need to know these relationships. Okay, but notice how just by knowing the initial one, v equals d over time, okay, you can then just rearrange the equation for whichever one you need. All right, second thing I want to say, anytime you see an equation with fractions, your first goal should be to eliminate those denominators. So we got to ask ourselves, what are we going to multiply to both sides of the equation that's going to eliminate both the 60 and the 700? Okay. Well, now I'm going to need 700 to be part of it to cancel out with this one here. But do I actually have to multiply that by 60? No, because you see they have a common factor of 10. So I'm just going to use not 700 times 60. I think I just need to use 700 times 6, which is just 4,200. So I'm going to multiply both sides by 4,200. Okay, so let's distribute this on the left. Okay, so the 4,200 is going to reduce with the 60. Okay, if you're not sure, in fact, just to be sure, let's use our trusty calculator here. Okay, 4,200 divided by 60. Yeah, it indeed does reduce nicely. So that's 70b. Okay, plus, 4,200 divided by 700. I think that one there, we don't have to do any work. Okay, that's just going to be equal to 6p. And here, well, here, let's use our calculator for 7 times 4,200. Okay, 7 times 4,200 equals 29,400. Okay, so now these are the equations I'm going to be working with. Okay, and again, I could use substitution. B and P are both easy to isolate, but I just prefer using elimination. And I'm definitely going to eliminate the P's, because that means I just have to multiply equation 1 by 6 instead of having to multiply it by 70 if I wanted to get rid of the B's. So I'm going to take 6 times equation 1. Okay, so it's going to be 6b plus 6p equals 6 times 1900. So let's see what that is. 6 times 1900 is equal to 11,400. Okay, 11,400. And here I'm going to subtract these equations to eliminate the p's. So 70 minus 6 is just going to be 64b. 6p minus 6p is 0. And here, again, I could do that in my head, but just to be clear, and just to make sure I don't make a mistake, 29,400 minus 11,400 equals 18,000. Okay, and I'll leave that on my calculator because the next step is to just divide both sides by 64. So let's divide 18,000 by 64 and we get 281.25. Okay, B is 281.25. Okay, and now I'm just going to use equation 1 to solve for P. So 281.25 plus P is equal to 1900. So P is just 1900. Okay, 1900 minus 281.25. And 1618.75. Okay, so let's just give our final answer. Okay, traveled 281.25 kilometers by bus. Okay, and 1618.75 kilometers by plane. And there's our final answer. Okay, so just to recap here, the question told us what we were looking for, the two distances. So that allowed us to write an easy equation. Adding the distances gives us 1900. The problem is that the second equation involved time. But we used our relationships between velocity, distance, and time to rewrite that equation as an equation in terms of our variables b and p. Okay, and don't forget, when you see an equation with fractions, step number 1 is eliminate those denominators. And then from there, it's all the usual steps you're used to. Okay, that's it for this one.